Hi, my name is Yaswant, and I am proud to show you today one of the demos that my team has been working on for the past year. This demo is all about detecting Kuiper Belt objects, and I hear some of y'all probably asking, what the heck is a Kuiper Belt object? Well, the Kuiper Belt is pretty similar to the Asteroid Belt. So the Asteroid Belt, some of you may already know, is this belt of objects between Mars and Jupiter. It consists of asteroids, comets, and minor planets. The Kuiper Belt is pretty similar. It's composed of asteroids, comets, and minor planets, just like the Asteroid Belt, except it's beyond Neptune. It's really, really far away. So if you look at this image is showing you the path that the New Horizons spacecraft took. The New Horizons spacecraft, some of you may remember, is the one that took those beautiful images of Pluto a couple years ago. And so this image is showing you where the New Horizons launched from, when it passed Jupiter, when it passed Pluto, and where it currently is, flying through the Kuiper Belt. Sometimes these objects are known as KBOs for Kuiper Belt objects, so you'll see that a couple of times. But the most important thing to remember here is that the Kuiper Belt is really, really, really far away from the Earth, which can make some of the objects there difficult to detect. Now, normally for asteroid belt objects, finding them is pretty simple. You just look at a small patch of the sky, and you look at it every night for a really long time. And you'll notice that there's going to be a whole bunch of different bright dots in the sky. Some of these are going to be stars, and stars are really, really far away, so you don't really notice them moving very fast. However, asteroids and comets are going to be really, really close to us, and so we'll see them moving very quickly. And because of that, if you look at the same patch of sky every single night, and one object seems to be moving really, really fast, while everything else is sort of staying stationary, you can pretty much guess that that fast-moving object is probably an asteroid. This works really, really well as long as the object is pretty close to us, it's pretty large, and it's pretty reflective. And we've been doing this since about 1801, which is when the first asteroid belt object was detected. But looking at the Kuiper Belt, it's going to be a little bit more difficult. As it turns out, the Kuiper Belt objects are too far away to reflect sunlight, so you can't just look for bright objects because they're not going to be bright. They're still moving pretty quickly, though, and they block starlight out as they move, and this is called stellar occultation. So what happens is, if you look at a row of stars and you can catch them sort of glimping, blinking in and out in a sequence, you can trace out the path of these Kuiper Belt objects over time and sort of discern where they are and where they're going and how big they are. You can even start to draw out outlines of these Kuiper Belt objects, which is something we did with this object known as erikoff, sometimes called the snowman asteroid. So a couple years ago, they discovered it had this really weird snowman shape using the stellar occultation method. It took observations from 24 different telescopes to figure this out, but when they looked at the trails of these stars and where those starlight blinked in and out, they were able to trace this weird shape. And then not that long ago, the New Horizons spacecraft flew past it and was able to take a couple of images of it, confirming that it is in fact this weird snowman-shaped asteroid. What they think happened is that two asteroids a long time ago sort of slowly started falling into each other because of gravity, and then now they're sort of attached to each other and it's a single big asteroid. And that's basically how we figured out what the shape of it was and sort of a lot of really, really interesting properties, just by looking to see how it's blocking out the starlight. Of course, this took the work of 24 telescopes in many, many years, which is probably not something that's available to most people or most classrooms or whatever. So what my team and I have been working on for the past year as a project is to demonstrate how this stellar occultation method works using nothing more than fairly common ingredients that most people probably have laying around their house. The idea being that you could recreate the science behind this in a classroom setting or maybe for a science fair or something for relatively cheap. And that's what I'm going to show you next. So here we have the demo that we've built, basically. So I've gone ahead and drawn out the shape here to help visualize it a little easier. But you can see these dots moving around to sort of represent the movement of stars in the sky, as you would when you're observing. And you can see that some of these stars seem to be blinking in and out because they're being blocked by the shadow of another object. In this case, our mystery Kuiper Belt object. And when you trace out where the star is blinking in and out, you get the rough shape of a square here. And if I pan the camera up, you can see that, in fact, it is a roughly square-shaped bottle cap. Not a perfect square, of course, because of the orientation that it's at. But in real life, you would be able to get much more data points as you observe the object from many, many different angles. Here we can only see it from one angle, and so that's why you see this little square shape here, but it's not that far off. You can even see that it's a little bit of an angle, and we can capture that angle. What you'll also notice that this whole setup is very, very simple. This entire demo cost under $20 to build. The biggest cost was buying a motor to move around at a relatively slow speed, but even that was relatively cheap and easy to find. The idea behind this is we wanted to show that you could build this entire thing and show off the concept behind things as complicated as stellar occultations relatively easily. You could easily replicate this for a classroom or for a science fair or just for a fun little project. And of course, with adult supervision, children of almost any age can help out and build this thing. And you can use a variety of shapes. You know, it doesn't have to be this. You can use snowmen, triangles, stars, whatever shape you want to use. And you can test out how those will affect the appearance of the star shells and with the stellar occultations as much as you want. So this was a really, really neat project to work on. And I hope some of you feel inspired to maybe try to build your own